The controller in an ASP.NET MVC application is a very powerful feature, but one that's reasonably easy to use. Like virtually everything in a .NET application, controllers are .NET classes that implement properties and methods. The system.web.mvc namespace has a rich infrastructure for building controllers, designed in a way that your controllers are likely to need very little code, only what is necessary to implement the custom features of your application. All of the routine infrastructure of controllers is encapsulated in the base controller interface and the classes. It's important that you learn about and understand how the controller is implemented in the system.web.mvc namespace that is installed with ASP.NET MVC. Ultimately, a controller is a controller if it meets two simple requirements. First, that it implements the iController interface, and the name of the class ends with the string controller. Now, the class also has to be marked public, not abstract, and cannot take generic parameters. These are implementation details that, if violated, will prevent instantiating the class as a controller. If the class doesn't meet these requirements, MVC can't recognize it as a controller and will never call any of its action methods. But normally, you're going to create controllers that inherit from the controller class, which itself inherits from the controller base class. It's the controller base that implements iController, and both controller classes add the significant features that make writing MVC applications as easy as it really is. What we're going to do now is explore the iController interface and the two controller classes. Even though you're likely to only create controllers that inherit from controller, for reasons that you'll understand shortly, it's helpful to understand how all these classes together provide features to your controller classes. So let's start with the iController interface. The requirement that controllers implement the iController interface really isn't asking all that much of your controller classes. The interface's single purpose is to provide a way for ASP.NET routing to find a controller and call an execute method. It has a very simple interface definition. This is the code that implements the iController interface directly from the source code of the system.web.mvc project. That source code is written in C#. There's not a VB version of it. When a request comes into your application, when the user does something within the view, clicks on something, whatever, the routing system is going to identify a controller and call its execute method. And it'll pass in an object that contains information about the request. This request context object is quite robust. It includes an HTTP context object that exposes objects like request, response, server, session, and plenty more. And you can use various kinds of information from the environment as well. So let's take a look at some code that implements this iController interface. All of this means that to qualify as a controller and meet the requirement of implementing the iController interface, all you have to do is implement a single method execute. So here's the code for the basic controller, one of the controllers in the sample application for this section. It implements the iController interface, and in order to implement that interface, it has to provide the execute method. Now this is just about the simplest implementation of a controller that you could ever think of doing, just about. So the execute method gets in an instance of this request context object, and it uses that to get reference to the HTTP context object. This is the same HTTP context object that you may have used within your web forms application. That exposes a response property, and then you can use the write method of that response object in order, in this case, to write a string out to that page. So I'll go ahead and run the application. And I'll click on the basic controller link, and as you can see, it writes out that string. Now it's very important to understand that this is the complete contents of this page. All we did is we used response.write to write out some text. There's nothing else. There's no HTML. There's nothing else there. You could use this technique in order to write out much more complex code, say by building up HTML within code within the page. But the idea here is that iController is functional. You can create pages using it and hook into some of the very rudimentary features of an MVC application, but it doesn't offer very many features. This is intentional because what it does is it allows anyone with, frankly, a lot of time on their hands to use the interface as a starting point for building a custom controller framework and then hook it into ASP.NET MVC. But for writing everyday controllers, you can do way better by using the controller classes that are part of the system.web.mvc namespace. So let's explore those classes. One level up from iController is Controller Base. This is the abstract base class for controllers that implements some of the features that make writing your controller classes very easy. It implements iController, so any class that inherits directly or indirectly from Controller Base will already meet one of the two requirements for being an MVC controller. Controller Base adds the temp data and view data properties that let you share data between a controller and a view. The class's execute method creates the controller context object that provides context for the current request. Still, the controller base class is pretty lightweight and adds only a little additional functionality to iController for the purpose of creating your own controllers. Now you could build a website using iController or Controller Base, but it would either be a very simple site or would require a ton of code to implement even the most basic features that users expect in this era of web applications. Most real-world applications should create applications that inherit from the controller class, which adds far more significant functionality to your controllers. The system.web.mvc controller class is a rich implementation of all of the infrastructure you'll need to write clean, very simple controllers in an MVC application. It inherits directly from Controller Base, so indirectly implements the iController interface, which meets that requirement to be a controller. It also adds a number of very powerful features for controllers that inherit from controller. One that you'll use a lot is action methods. A controller can implement various methods that go far beyond that single execute method. Depending on the route definitions that you have defined within your application, each action method is exposed by a different URL and can accept parameters. You also get action results. Each action method can return one of a rather large number of action results, which are objects that describe the intended result of the action. You might return a simple string to a page. You might implement a complex view full of HTML, and that's probably the most common thing you'll do. You can redirect to another page or an action method. You can return snippets of HTML code, and there's lots of other options. There's lots of flexible things that you can do with action methods. And the controller class also implements filters. These are reusable behaviors that you can associate with a controller. And that lets you do things like use caching, control what users or groups of users can access a controller or action method, and a lot of other things. And you can create your own filters. In order to take full advantage of all these features, you'll always want to create controllers that inherit from the controller class. In fact, there's really no good reason to use iController or Controller Base, unless you really want to get down and dirty with the code. And so that's the approach that we're going to take throughout this course, inherit from the controller class. By doing so, all of the controllers that you implement become containers for action methods. And that's where you get the simplified code. It lets you write custom application code without repeatedly writing and rewriting the common infrastructure kind of code. Now, in order to use controllers effectively, you have to have at least a basic understanding of the MVC request processing pipeline. Every time a user makes a request of an MVC application, such as by clicking a link or a button, then IIS, ASP.NET, and the MVC framework collaborate to run the request through a processing pipeline. The same thing happens to requests made to an ASP.NET Web Forms application, but the pipeline is entirely different from that used in MVC. Let's take a look at a simplified version of what happens for a typical request that is channeled through a controller that inherits from the controller class. And in this case, the request is going to be directed to an action method and then ultimately present the user with the view. There are lots of other options available at each step that lead to a different set of steps, such as if the controller is built by directly implementing the iController interface. But what we're going to talk about now is the most common process for a typical MVC application. So we have a request that comes through. The user does something, clicks a link, or a timer goes off, or something happens to cause a request. And that goes via HTTP from the browser to the server. IIS passes this on to the routing engine, which parses the request into its parts, including the controller name, action method name, and maybe an ID value and maybe some additional query string parameters. Then the controller factory, specifically the class named default controller factory, uses the routing data to instantiate the controller class specified by the routing data. So now the controller is in memory. Then the controller uses an action invoker. The class is called controller action invoker in order to select and invoke the appropriate action method. And this can actually be a fairly complex process because you may have many overloaded action methods with the same name. But the action invoker is charged with selecting the correct action method. So assuming that the invoker finds an appropriate action method, it then executes the method. And that culminates in a selection of a view to return to the user. And it returns that view via HTTP in the form of a response. But there are other forms of responses as well. So that's the overall request processing pipeline. Now let's talk a little bit about how the action invoker selects the correct action method from all of the possibilities. Now, the primary job of the action invoker is to select that appropriate action method. So it really can be more complicated than it might appear. There could be, as I mentioned, multiple overloaded methods with the same name. Those various overloaded methods could be decorated with attributes that control its use. In which case, their selection, or the selection of an action method that is decorated with a particular attribute, may mean that that particular version of the action method is appropriate in some scenarios, but not others. And furthermore, an action name may be different from the method name. And there's lots of other kinds of complications. So designing an effective controller requires that you understand how the selection process works. The first thing that the action invoker does is to look for the action portion of the route definition for the request. It does this using the default route defined in a new MVC application in the form shown here of controller, action, and ID. But you can define other forms of the routing. So it's looking for the action parameter. But even if the current URL doesn't include that action portion of the URL, then the default route definition defines it to be the index action. And then, once the action invoker has the name of the action, it needs to map that action name to a method of the controller. The simplest case occurs when there is a single method in the controller class with a name that matches the action name. For example, in a brand new MVC application, the index action of the home controller maps to the index method in that controller. There's only one index method within that controller class. But what qualifies as an action method? Is every method defined in the controller a potential action method? Nope, not at all. There are a few requirements that a method must meet for the action invoker to consider it to be an action method candidate. The first one is that it must be public and not static or shared. It also cannot be a method defined on system.object or the controller base class. In other words, it must be defined within your custom controller object, not inherited from another object. So, for example, ToString could not be an action method because it's defined on system.object. It also cannot be a special method, such as a constructor, property accessor, or event accessor. Finally, it also cannot have the non-action attribute decoration. This attribute is handy if you want to include a public method in a controller, but don't want to use it as an action method. Taking all of these restrictions into consideration, the action invoker uses a reflection to find all of the methods in the controller with the same action name as the action name specified in the URL and meets the above requirements. But here's where things get a little bit murkier. Through the use of attributes on those methods, there could be multiple methods with the same name, but the action name could be different from the method name. And there may be a selector attribute that restricts what requests an action method can respond to. This can create a bit of a gauntlet the action invoker has to navigate to find the correct action method. So next what we're going to do is explore those action method features a little bit. But be aware that by default, anyone anywhere across the internet, assuming this is a public internet site, anyone anywhere can invoke any public method you create in a controller, unless you decorate the method with the non-action attribute. Now that sounds a little bit scary, but most of the time you're only going to include action methods as public methods within the class. So it really isn't an issue. Just be aware of that little possibility. So one of the attributes that we need to talk about is action name. The normal convention is that the method name that you define in the controller is also the action name. This is generally what you should do because it keeps things simple and straightforward. But you can also give an action method a different action name. Keep in mind that the action invoker matches up the route action name with the method's action name, which may not be the same name as the method within the controller, which is a little bit confusing, but bear with me. We'll straighten it out. Now, why might you want to give a method a different action name? Well, one reason might be that you want to use an action name that's not a legal language method name, such as a keyword in C# or Visual Basic. Another reason is that you want to use an MVC component name as the action name, such as view, literally the name view, which would conflict with the view method of the controller object. Or maybe you want to use a different naming standard for action methods and controller methods. Now, none of these are things that you should do lightly, but it's good to have the flexibility when you need it. So let's take a look at an example to hopefully sort all this out. Let's say that you have a method defined in the home controller called getAuthor. So we have this action method here. It's in the home controller of the sample application. Obviously very simple. All it's doing is returning a string. So I'll go ahead and run the application. And click on the getAuthor link. As you can see, the format of the URL is home, the controller, and then the action method name, getAuthor, and it returns that string. But this looks a little bit funky. Let's say that we want the URL to be not home/getAuthor, but we want it to be home/author. But we want to leave the method name the same within the controller, for whatever reason. All you need to do is apply this action name attribute. I have it commented out there. What that's doing is it's telling MVC application to look at that getAuthor method as having an action name of author. So I'll save that change, run the application again, and what I'll do first is click on that same getAuthor link. As you can see, now I get an HTTP 404 error because the getAuthor action method no longer exists. The action invoker went through its gauntlet of looking for the appropriate action method and didn't find anything called getAuthor. What I need to do instead is use this other link called AuthorAction, and now you can see that it's home/author, and now we got the response that we expected. So it's important to understand that the getAuthor method is now invisible to ASP.NET MVC. You can't use that action method name any longer. So I'll shut down the page, and we can come over to the Home Controllers index view here and see the action links that I used in order to present those on the page. The first one, this is the text getAuthor that displays the text on the page, and it calls the getAuthor action method of the Home Controller. But if I rename it, this is the text again that is displayed, but I have to use the author action name when I'm using that attribute because getAuthor no longer exists. Once the action invoker has identified all of the controller methods that match the desired action name, it examines the action method selector attributes of all the candidate methods. You can decorate a controller method with this attribute to control under what conditions a controller method should agree to handle a particular type of request. The attribute defines only a single method, isValidForRequest. The action invoker executes this method on each candidate action method. If the isValidForRequest returns false for a controller method, that method is removed from the list of candidate action methods. The ASP.NET MVC framework includes several implementations of the action method selector attribute. One is non-action attribute. I mentioned this a little bit earlier, but a controller method with the non-action attribute is immediately removed from consideration. So that's how you can include public methods within this class for other uses, but it won't be usable as an action method. The accept verbs attribute is a little bit more interesting. It uses the HTTP verb of the current request to determine whether the method should handle the request. That means that you could have multiple overloaded methods in the controller class designed to respond to different HTTP verbs, such as get, post, delete, etc. It takes a single parameter with a list of HTTP verbs that the method will handle. But easier to use are some additional attributes that were introduced with MVC2. These derive from action method selector attribute and include HTTP delete, HTTP get, HTTP post, and HTTP put. Each corresponds to a single HTTP verb and accepts no parameters. So let's see how this works. Here's the action controller class that was created as part of a new MVC web application. And it implements two versions of the register action method here. They're overloaded. One takes no parameters, and the other takes a register model parameter. Now this latter method is decorated with this HTTP post attribute, which means that this version of the action method is only going to handle requests that use the post verb. This other register method will handle requests that use any of the other HTTP verbs, and most commonly it's going to be the get verb. Because the way this works is this is the action method that originally presents the form to the user to register, and then this is the action method that is called in order to process the data that the user enters within that form. All right, so once the action invoker has run the complete gauntlet, it should have whittled down the list of candidate action methods to exactly one. If there still remains more than one candidate that can handle the request, then the action invoker throws an exception indicating that there's an ambiguous match. But if there's no method that can handle the request, the invoker is going to invoke the unknown action handler, which is actually the handle unknown action method of the controller class. By default, what this method does is it returns an HTTP 404 status code indicating that the resource was not found. But you can override the method and do whatever you want to in response. So let's take a look at the home controller. And here I've implemented that handle unknown action method. So let me remove the comments here. And that now makes it active. And all we're doing is we're just using response.write to write a string out to the page. I'll go ahead and run this. And I'm going to use this doesn't exist link here, which is going to attempt to go to the home/non-existent URL, literally non-existent action method. I'll do that. You can see the URL there, and it displays that string. Now, in a real-world application, you're probably going to want to redirect to some kind of error page, something more than just an ugly string that you present to the user. But you can basically do whatever you want within that handle unknown action method.